Hello students, today we are starting a new chapter, oscillations. As in our daily life, we all see various kinds of motion. Say for example, non-repetitive motion. In this category we can put rectilinear motion, projectile motion. Whereas there are other categories of motion, periodic motion, oscillatory motion. First we will consider the case, what is a periodic motion? Just take an example. See in this figure, an object A is moving along a circular path with respect to a position at the center of circular path, which is O. In this kind of motion, when the object A starts its motion and again comes back to its initial position, a cycle is completed along the circular path, and again the object A repeats in its motion in the clockwise direction. It is clear from that figure. So this kind of motion of a particle is known as a periodic motion, where the motion of the particle is repeated after a definite interval of time. And what is that definite interval of time? That interval of time is that in which the particle completes a circular path, or the particle moves in a complete cycle. So a periodic motion is that which repeats itself at regular interval of time. We can take here so many examples of a periodic motion. Say an example, an example, uniform circular motion of an object. Another example here we can consider orbital motion of planets. In our solar system. See here, there is another kind of motion which is known as oscillatory motion. We can define it a motion which is periodic to and fro motion about a mean position. See in the given figure, this is the condition of movement of a pendulum of a wall clock. Say here at the initial position, the pendulum of wall clock is at the horizontal position at rest, and this position is expressed here in the diagram along the position OA. Now from the point A we drop that pendulum and after that it moves towards the position B and then comes forward to the position C, which is again an horizontal position with respect to the point O where the pendulum is fixed. After reaching at the point C, the pendulum moves again towards the point B and then again towards point A. So the bob of the pendulum, the lower or bottom part of that pendulum, is moving from A to B position towards C and again repeats from C to B towards A. It means the pendulum is completing an oscillatory motion where its motion is repeated because it is coming back towards the point A after each oscillation, and since the time of each oscillation will be a definite time interval, a periodic time, and this motion will be repeated after time and time, so this type of motion will be called as the oscillatory motion. So here we can give the example for an oscillatory motion, the movement of a pendulum of a wall clock. Motion of pendulum of wall clock. Similarly, we can give here the another type of example for the oscillatory motion. Children swinging on a swing. The another example we can give here, the movement of surging pistons in engine of cars, vibrating membrane in drums. So these are some common examples which you can put here for oscillatory motion. Now always remember one thing, every oscillatory motion is a periodic motion, but it is not necessary that every periodic motion will be an oscillatory motion. In case of a circular motion, where an object is moving along a circular path, its motion is not such type of motion where the particle or the object is moving to and fro with respect to a mean position, but its motion is periodic. So here is a note 1 which you must remember, every oscillatory motion is a periodic motion, and a periodic motion may or may not be an oscillatory motion. The one more thing you have to remember here, higher will be the frequency of the oscillation, lesser will be the time period. So the displacement is in terms of vibration, whereas the oscillations at the low frequency rates will be called as only the oscillation, not the vibration. Oscillations at higher frequencies is known as vibrations. Now we will discuss some terminology which will be used here throughout the chapter to study the oscillatory motion in different categories or stages. So we will first discuss the various terminologies in this chapter. First we are taking here the period of oscillation, that is expressed as capital T. It is known as smallest time interval after which a motion is repeated. The second one, frequency, which we denote here by, it is known as number of oscillations. So from this term relation, we can define here F equals to 1 upon T, and its unit will be given here. Hertz, or 1 oscillation per second. So that is enough for today. We will continue in the next turn, where we will discuss the displacement of the particle where it is oscillating, and another type of an oscillation, the simple harmonic motion. Till then, good day.